All right. Welcome to Let's Read the Fucking Manual with Papa Dada. Today we are doing a test. Test run. Let's talk about it. We're going to read a manual on the Model 1066 rack mount stereo compressor, limiter, and gate from DBX by Harman. I bought this used from a local used music shop, Atomic Music, in Beltsville, Maryland. Check them out. They generally have pretty good shit, which I'm pretty happy with. So we're going to run the compressor. What we're running through the compressor today to test signals is this little Boss DR110. Right, and you can hear it there. And then I'm going to hit stop. But yeah, that's where that drum beat's coming from. The reason I like it is, there's not individual signals for individual drum beats. If you hear a change in this, that change is going to come from the compressor because I'm just hitting start and stop on that drum pattern. So, page 1, Model 1066 Operation Manual. Looking very exciting. Page 2, Safety Info. Risk of electric shock. Oh, this is a lot of BS, basically. Keep these instructions, heed all warnings. Follow the instructions. Don't clean it with a hose or a wet sponge or anything like that. Don't install it near any heat sources like radiators. Don't fuck around. You're going to find out. We don't want to do that. That's page 2. Page 3, Declaration of Conformity. I mean, this is just a whole bunch more plug stuff. It uses one of those IEC cables, the transformers switchable. Blah, blah, blah. Don't hack together your own plug cable, stuff like that. We're not super worried. That's not how I roll. I was raised better by my dad and grandfather. Page 3. Oh, here, we got to do the page down. Blank page. All right, this is going to be a short and sweet manual. Contents: introduction, inspection, warranty, connecting the 1066 to your system, operating controls, applications, installation considerations, and specifications. Cool. Introduction. Congratulations and thank you for your purchase of the DBX 1066 compressor. The DBX 1066 is a high-performance multifunctional unit designed to deliver all the flexibility and power that a professional user demands. The DBX 1066 incorporates the new advanced DBX V2 registered trademark VCA, a voltage-controlled amplifier, for high system performance. We recommend you take a moment to read through this operation manual, which is what we are doing together today. It provides information that will assist you in system setup, inspection. Verify that the 1066 package contains the following. Now, I told you I bought this used. I got the rack mount, plug it in. Most of the LEDs work. They gave me an IEC or whatever it's called, the pretty standard it's a hexagon, but it's not like equal hexagon. You guys all know the plug. Everyone out there, all the people following, the plug. For rack mount screws and washers, I had to find those myself too. In any of these items are missing contacts, so that's cool. If you buy it new and you're missing something, call them directly. Warranty. The warranty registration card that accompanies this product must be mailed within 30 days after purchase date to validate this warranty. Proof of purchase is considered to be a burden to the consumer. DBX warrants this product when bought and solely used within the United States to be free from defective materials and workmanship under normal use and conditions. DBX liability under this warranty is limited to repairing or at the discretion replacing defective materials that show evidence of defect, provided the product is returned to DBX with return authorization from the factory, where all parts and labor will be covered up to a period of 2 years. This is definitely more than 2 years old, so I'm not worried about that. Return authorization number must be obtained from, oh my God, call up on the phone. Jeez. The company shall not be liable for any consequential damage as a result of the product's use in any circuit or assembly. DBX reserves the right to make changes in design or make additions to or improvements upon this product without incurring any obligation to install the same additions. There's some cover your ass CYA language. If they're not going to do formal model numbers, they're just going to, they make an update. You read a newer manual, whatever. The foregoing is in lieu of all other warranties expressed or implied, and DBX neither assumes nor authorizes any person to assume on its behalf any obligation or liability in connection with the sale of this product. In no event shall DBX or its dealers be liable for special or consequential damages or from any delay in the performance of this warranty due to cause beyond their control. So I don't know if do they still sell this new? I feel like I should look that up. DBX 1066 new. Yeah, no, that's used. Those are used. Those look used. I don't know. I'm here. Sorry, I'm over looking on Google. I see a whole bunch. Well, this one's even cheaper than what I paid. I bought this a minute ago. Oh, 125. So maybe they got a new one on Reverb. If it's Armin's in New York, it's going to be overpriced. Their shit's always overpriced. Used excellent. Oh, 352. That's not cheap. Do we see one new? Do we see a new one? Excellent, 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 excellent. So I don't know. You guys are going to be SOL on that warranty. I don't think it's a thing. Not a thing. So don't worry about that. Let's get back into it. Connecting the 1066 to your system. Turn off all equipment before making any connections. Mount the 1066 in a rack. As you can see, I've already mounted it. I used the rack screws that came with my output desk, which now is made by DeFi, I guess is the company. Solid desk. My mom bought it for me as a housewarming present. It was not cheap. I've really loved it. I've had it for the last 3 years. It's got these 3U rack mount drawers in the top. It's solid. Make audio connections via XLR, 1/4-inch T RS tip ring sleeve, or 1/4-inch TS tip sleeve plugs. Both types of connectors for the inputs and outputs can be used for balanced or unbalanced connections. The use of more than one connector at a time for the input-output pair could unbalance balanced lines. So don't run two TRS balanced lines from one mixer and then two XLR lines from another mixer, because you could get phase. It's short of conductor ground. You can get phase cancellation. You can get a lot of things. What you will see, which I will turn this camera mount over, is that I've got everything running through a patch bay over here, which we'll talk about a little more in a minute. And yes, I will be doing the Samson S Patch Plus read the manual in the near future. That's part of the existing gear I am reading through the manual of with you fine folks. So yeah, apply power. I connected the power. It's going into these Radial Engineering Power 1s, which you can see just below the 1066. And then turn the bad boy on. Very cool. Front panel. We can see the front panel right here. So we've got, interestingly, the stereo link switch is the first thing that they point out. And that is this little guy that's lit up right here. I have it clicked, and that way we don't have to worry about the two different channels. They have identical controls on the left and the right. So we have first the expander gate control. And we'll get that nice and zoomed in, right? So we've got that expander gate control. Stereo link switch. Stereo link switch. This switch changes the 1066 from 2 independent compressors into a stereo compressor. In stereo mode, channel 1 is the host and channel 2 is the linked channel. Each of the channel 2 controls and switch functions will be overridden and controlled by the channel 1 controls and switches, except the sidechain monitor, sidechain enabler, contour, and bypass switches. Also, channel 2's expander gate, compressor threshold, and peak stop plus threshold meters will be disabled, while both channels' gain reduction meters will identically indicate the amounts of gain reduction occurring. It is important to note that while channel 1 is the host as far as the controls go, both channels have equal precedence as far as signal processing is concerned. The DBX 1066 uses true RMS power summing, registered trademark, an extremely accurate and musical way to combine detector outputs in a stereo situation. The switch will light to indicate that the 1066 is in stereo link mode, and we can see that, boom, it is lit. Oh, move that over to where I'm pointing again. It's lit. What's up? Cool. All right. First couple buttons, or first couple knobs. Expander gate threshold control. This control sets the level below which gating expansion occurs. It has an effective control range of negative 60 decibels to positive 50 plus 15 decibels. When it is fully counterclockwise to the off position, no gating or expansion occurs. Now, you will notice that I have pretty much both of these off. I have the ratio of the expander gate turned all the way down. The threshold is turned off, and that is because I will use this compressor as a proper compressor, but I'm not using the gate function. At least I wasn't in a moment. I was actually mostly using the sidechain function. Expander gate threshold below LED. This LED illuminates when the signal is below the level set by the expander gate threshold control and indicates the expansion or gating is occurring. Expander gate threshold above this LED illuminates when the signal is above the level set by the expander gate threshold control and indicates that no expansion or gating is occurring. Ratio control. This control sets the expansion ratio and varies from 1:1 to 8:1. It is important to note that as the signal passes below the threshold, the input-output gain relationship does not transition sharply from unity gain, that's a misspelling, interesting, where no expansion is occurring, to the ratio set by the expander ratio control. The 1066's expander utilizes a soft knee over easy threshold circuit, analogous to the over easy compressor curve made famous by the 1066's predecessors and employed in the compressor section of the 1066. See Figure 1. This soft knee contributes to the smooth and natural sounding decay of the 1066 expander, making its action virtually transparent with low to moderate ratio settings. When hard gating is required, higher ratio settings cause the expander to function like a gate. The expander attack and release times are program dependent. The detector intelligently senses the need for fast attack for rapidly changing signals and slows down for more stable signals. So, if we hit play, right, we can see currently, because the expander gate is turned off, that we're not seeing much of anything. Right? Oh, hit the mouse. Hit the mouse with the drum machine. Sorry about that. So, let's see what happens. Can we get... All right, we can get the LED to illuminate when the signal is below the level set by the threshold. What does that do for us, though? Do we hear a difference? Maybe we turn the ratio up. Still not hearing much of anything. Here. I don't know, maybe it's subtle. Here's the question. So that hi-hat, that open hat. Oh yeah. If we turn the threshold down. Yeah. But we turn the threshold down. This is what we're hearing, right? It's all the way turned down, so it's off, right? So this is the open hi-hat, no choke from the closed hi-hat. We'll get to the choke group and all that, but we listen. Nice long decay, right? Crash cymbal. Nice long decay, right? So then we turn up to say -60, and we listen. Can we really hear? Maybe up to 40. Yeah, that definitely that was shorter. So what that does is that open hi-hat, instead of being choked by the closed hi-hat or being left to its complete decay, the gate is, as it's decaying, right? As that decay on the envelope is coming down, it's when it gets down below the setting that I have on the threshold, it's cutting it off. Right? That's cool. Oh yeah, look at that. So I'm not choking that at all. I'll show you. Right? And then the cymbal, that's the ride cymbal, so you can. Very cool. Very interesting. So then let's turn that up a lot. And I mean, it's subtle, you know? It's subtle. It's there, though. Turn it up a little more. All right. Cool. So that's what the gate, the threshold, and the ratio are doing. Very cool. Very cool. Very cool. I'm going to turn those back off. So that is the expander gate and ratio control. Very cool. Next page. Okay, and this is where we were listening to the figure with the threshold versus the over easy curve. I think the auditory example, the audible example that I just gave explains what's going on a little better than a graph. Graph does exist. So if you want to know, exactly what's happening to the output level against the input level, cool, right? Except that this makes it look like, like if it'd be, I guess if you had in the ADSR, like if you had in the envelope an attack that was non-existent, where it was like a right, like almost like a reverse of the symbol, then it would it'd have this weird, it wouldn't get that initial quiet part because the gate would only let in the signal above a certain, it's basically the gate only lets in the signal when it's big enough, when it's loud enough. Now we get into the next section, sidechain. Sidechain, that's what I like, right? So, of course, if you're a fan of Daft Punk, you've heard about the 3630, the 3630, and that whole French house like pumping sidechain. That's a very popular thing. And I say that because, we're talking late 90s, house revival, but people have been pumping sidechain a long time before that. And they'll continue to do it a long time after that. I like sidechaining more for what we would call the kind of like broadcast use, right? So when you're listening to the radio, or maybe you're young and you haven't really listened to broadcast radio much. I know it's kind of a dying platform, but if you listened to radio like I did as a kid, you would hear music would start playing. So I'd start playing the next song, and then the DJ would start talking. All of a sudden the music would get quieter, right? And then the DJ would stop talking, the music would come up, and the DJ would start talking again, the music would get quieter, and that's called ducking. And that's what I'm going to demonstrate today with the side chains. So what I have, again, is I have in my patch bay over here, the front end of the sends and returns of the side chain, and I have the mixer that this microphone's going into, which is a Scarlett 18i20 attached. It's in a rack attached to my MacBook, but I don't stream with my MacBook. I stream with this Lenovo. But the microphone, basically, what's nice is that it means I can play Ableton or whatever. I can play these synths in the background all through the 18i20, and then just the channel 9 and 10 monitor out go into this Mackie Big Knob Studio Plus that goes into this PC, and then the processor and OBS Studio and saving and all that, kind of bandwidth on the CPU and on the drive aren't affecting when I'm doing stuff with Ableton and soft synths and things like that. So separate animals, not to be worried. It's cool because, again, this big Studio Plus, which is a cool as shit little studio mixer, and I'll definitely do a read the fucking manual on that. It's got 4 stereo pairs in, plus a talkback mic, plus a built. It's got a lot of stuff. We'll talk about it later. We'll definitely talk about that on a future video. So goes into that. I've got my little map of all my, here, show you a better picture of my patch bay so I know where things are. I just redid it for this demo. And I'm going to go into the return for channel 1 and channel 2 for the 1066 with the 18i20, and then start the drum machine. Right? Now it's stereo coupled, but remember it said earlier on the front panel that it said it in here, except the sidechain monitor, sidechain enabler, contour, and bypass switches, right? That's an important thing. We haven't talked about the bypass switch yet, but we'll get there. But what I'm going to do right now is I'm going to enable both sidechains. And then what's going to happen is when I talk, and let's make it more pronounced. Let's turn up the output gain. And then when I talk, the sidechain should turn down the volume a little bit. And then when I go back, right? Now I have over easy pushed instead of the sidechain enable. Right? So when I'm talking through the sidechain enable, you can hear the volume go down and then the volume comes back. Now the over easy is a soft knee. I'm going to turn that on. And what's going to happen is that when I talk, the softer knee is going to bring the drum machine back once I'm done talking. But with the over easy off, it gets louder almost immediately. And additionally, what I can do is turn up the threshold, turn down the threshold, turn down the threshold. I don't know. But yeah, it's supposed to cut off the volume. If I'm talking, it turns down, and if I stop talking, it releases. And that's the big deal, is that that's the big deal. Ooh, a little distortion there. That's rough. So yeah, that's side chaining. Very interesting. And definitely works a lot better. I don't know. I'm never sure what setting's the best setting for such things. Right? You set the, a little more distortion there. Turn up the ratio. And yeah, the ducking does work. I don't know. I'm a big fan. All right, we'll turn back down the output gain. Yeah. I don't know. How much gain reduction are we really getting? I always want to come up with the most extreme example. Right? So if I'm... Okay. So if we turn up the gate... So if we turn up the threshold on the gate... Oh yeah, now you can really hear it, can't you? Right? And then let's do the over easy. Oh, sorry. And when we do the over easy, I don't know. Can you really hear it? I feel like I can definitely hear the ducking happening. Can we hear it more if we turn the threshold up more on the expander gate? If we turn the ratio up at all, does it do anything? No. Oh, I keep bumping the damn camera. All right, then we turn the sidechain off and the drum machine off. Cool, sidechain. So that switch enables the in and out connections of the sidechain, allowing external processing of the detector signal. So that's most often you go through like an external processor. So you send the compressor signal to an EQ, and then in the EQ you pull out, I don't know where the S's, like all those sounds are. It's called de-essing because it gets rid of a specific frequency. Oh, the guy that says he's the 80s on YouTube. All the Espencraft. Espencraft does a far better explanation of how de-essing works. Go look it up on YouTube. But yeah, it has no effect if there is nothing plugged into the sidechain loop. However, the switch will still light, indicating the sidechain is enabled. We have the sidechain monitor switch. This switch connects the sidechain return signal to the 1066's output. This allows monitoring of any signal processing that is inserted into the sidechain loop to assist in setup. The switch will light to indicate that the side chain is being monitored and the main signal path is bypassed. How would we test that? So let's see here. I'm gonna turn off this mic's feed from the 18i20 plugged into the MacBook. Okay, and then no signal. Nope. And then if we do this, you should have a signal. Can you hear me? Oh no. I see it showing up. I don't know for sure. All right. Oh, all those pops. All right, I'm back. I'm also looking, it looks like my right channel is not quite doing what it's supposed to do. I may have to go and check some of the cables in the back from that side chaining. All right, compressor threshold control. This control sets a level above which compression occurs and has a 60 decibel range. Compressor threshold below LED. This LED illuminates when the signal is below the level set by the compressor threshold control. This indicates that the compressor is not compressing and is operating in its linear region. Compressor threshold over easy, the OLED. That's so in the 0. This LED illuminates when the signal is in the over easy portion of the compression curve. In this region, the ratio varies as a function of signal level between 1 to 1 and the ratio set by the ratio control. This LED is defeated when the over easy function is disabled. So again, if we hit start, we turn on over easy, we see when it goes into the over easy and when it comes out. And this region, the ratio varies as a function of signal level. Interesting. Yeah, I guess you can mess around with the ratio to try and get the over easy. Yeah, well. And then the over easy off. Cool. All right. Compressor threshold above. This LED illuminates when the signal is above the over easy portion of the compression curve and indicates that the full value set by the ratio control has been reached. If over easy is disabled, this LED indicates the signal is above the level set by the compressor threshold control and dynamic range compression is occurring. Over easy switch. Over easy provides a smooth transition from the compressor's linear region to the compressed region. This smooth transition greatly reduces compression artifacts and allows faster attack times and higher compression ratios while still maintaining the natural characteristics of the signal. The switch lights to indicate over easy processing is enabled. When conventional hard knee processing is desired, disable the over easy function. Right? So hard knee, you want to cut off. Right? So it's lower the threshold, up the ratio. Right, now I just turned the balance way down. Right, and that's hard knee. And then we push over easy. Right. Hard. So high threshold, low ratio hard. high threshold, low ratios, over easy. Low threshold, high ratio, over easy. Low threshold, high ratio, not over easy. Take it back where we were. Look at the figure 2, hard knee compression curve and over easy compression curve, soft knee, over easy, whatever, and threshold LEDs. Figure 3 shows the effect of 2-to-1 compression on a signal as it rises above and falls below the threshold. Below the threshold, the signal is not affected. Above the threshold, the output signal increases by only half of the increase of the input signal level. In other words, with a 2 decibel increase in input level, the output increases by only 1 decibel. Hence the 2-to-1 compression ratio math. Who would have thought you'd still be using it? Signal level. And this is an example of the input signal going above the threshold and being reduced by half in a 2-to-1 ratio. Next, contour switch. This switch adds a gentle low frequency de-emphasis into the detector path. This is extremely useful in keeping low frequency program material from muffling or punching holes in the compressed signal. This feature allows faster attack times and higher compression ratios with less artifacts. The switch will light, indicating contouring is active. Compressor ratio control. This control selects the ratio between input and the output levels for signals above the level set by the compression threshold control. It is adjustable between 1-to-1 and infinity to 1. Note, when over easy processing is selected, the ratio transitions smoothly from the linear to the compressed region. As the signal exceeds the threshold, the ratio approaches the ratio set by the compressor ratio control. Interesting. Now, gain reduction meter. This 12-stage meter shows the amount of gain reduction due to compression, expansion gating, or intelligent predictive limiting, registered trademark, displaying gain reduction from 0 to 30 decibels. Right? Oh, I keep bumping it. So we look at that gain reduction. We can see there's a little bit of gain reduction happening when those hi-hats are, right? When they're hitting a little bit. But then the kick is getting a lot more, and the snare. Yep. All right, attack control. The attack control sets the amount of time it takes the 1066 to begin compressing a signal once the detector has sensed a signal above the threshold. The attack range is from 3 decibels per millisecond for a tighter and more noticeable compression effect with very little overshoot, to 0.04 decibels per millisecond for more delayed gradual compression. A very fast attack setting will cause the 1066 to act like a peak limiter even though RMS detection circuitry is used. Slower attack settings cause the 1066 to act like an RMS or averaging detecting compressor limiter. So this goes back to that, right, with the big delete, the attack control, right? So we start a beat again. I mean, it sounds almost anemic when you turn the attack down, right? But then so when they say a tighter and more noticeable compression effect with very little overshoot, see how that gain reduction is popping out? Continue to up the ratio. Right, and that attack is, I mean, I don't personally like it on this particular drum machine at these settings, but it's a good example of how it works. And the snare, man. What a difference on the snare. Really, you got to get all the way down here to like the 1, right? That 1 range, 1 decibel, and then 3 decibels per millisecond. Takes out all that kick, takes out all that snare. Sounds like a, Casio consumer grade little drum beat out of a tiny speaker. Take it up to 1. Well, now it's okay. Now we start to get where the kick is cool, and maybe we'll stop it for a second and just kick. Right? Just the kick, just the bass drum. Just the snare. Yeah, pretty cool. All right. Release control. The release control, sorry, phrasing, sets how fast the compression circuit returns the input to its original level. The release rate is from 250 decibels per second, where compression follows the envelope of the program material very tightly, to 5 decibels per second for very smooth compression, right? So again, like, right? So if the release control is all the way to the left at 250 decibels per millisecond, right? That release is just like, here, I hit the bypass. Now, almost like white noise down here. All right, and then we're going to hit the full thing. All right, attack all the way up, release all the way down. Now we start to very smooth compression according to the right. So like when people are, you want to compress the shit out of those drums. Like, okay, we've choked the attack, and put a high ratio of return. We've dialed back the release, and then what do? We do some makeup output gain. Definitely sounds different, and if we bypass it, yeah, compressed, not compressed. All right. Peak stop plus level control. This control sets the level. Oh, wait. Release control. Auto switch. This switch overrides both the attack and release controls and enables preset program-dependent attack and release times. These times are derived from the input signal and continuously change to match its dynamics. Interesting. The switch lights indicating the attack and release times are being automatically adjusted in a program-dependent fashion. Cool. Enabling the auto function duplicates the classic DBX sound of the 1066 Forerunners, which have become standards in the industry. A little bit of and we already bought it, so I don't know what the sales pitch is for, but whatever. All right. So we start it again. right? Auto in both channels. That's the classic DBX sound. All right, we change the ratio a little bit. Put the threshold up. Threshold down. Threshold at 0. Ratio at 2.1. Auto off. Auto on. I mean, the gain reduction definitely goes up when the auto's turned on. You can hear some sort of difference. I don't know how big a difference you can hear. Yeah. Anyways, that's something. Cool. Input output level meter. Get that centered in there. This switch selects the signal for metering by the input output level meter. The switch lights indicating the input signal is currently being sent to the meter. When the switch is in the out position, the output signal is selected for metering and the switch will not be illuminated. Okay, so we hit start. All right, so lit up. This is the input signal. Depressed, unlit, output signal. We have an output gain. Yeah, turning up that output gain makes it a little more obvious, but cool. That's what that does. Oh, and speaking of output gain control, this control sets the output gain of the compressor. It can be continuously adjusted between negative 20 decibels and positive 20 decibels. Use this control to compensate for signal level loss due to compression and to adjust the nominal output level of the unit. And I know a lot of people when they say like, oh, well, you know, I'm going to compress my drums, but then that's going to take away the noise. And so like, how does compression make drums sound louder? And that output gain like really helps, right? You know, like we compress the shit out of our drums and then we turn up the makeup volume and boom, you know, you got it. Bypass switch. This switch bypasses the unit completely. A relay hardwires the input directly to the output and the signal is not processed in any ways. Cool. So, okay, so we hit start and then we bypass. Yeah, and the bypass, you know, that's unaffected signal. Peak stop plus level control. This control sets the level to which the output signal is reduced whenever it exceeds this level. Interesting. So we know we had the input output level, and when we did a lot of output gain, we're taking it up to like plus 12. And it can be adjusted between plus 4 and plus 22 decibels, which is basically off. Like if you go over, 22 dBu, and it's a different dBu is different than just regular decibels. But this peak stop plus limiter uses a DBX two-stage limiting process. The first stage is the instantaneous transient clamp, which clamps the signal with a soft logarithmic clamp function. This logarithmic function assures that the signal will not exceed the level set by the peak stop plus level control by more than 2 decibels typically, and that it will not introduce harsh artifacts. The second stage is a unique program limiter featuring intelligent predictive limiting, registered trademark. Its function is to monitor the input signal and intelligently predict the amount of gain reduction needed to keep the output signal below the ceiling set by the instantaneous transient clamp registered trademark. Note, since the Peak Stop Plus trademark limiter is a fail-safe limiter, it must come after the output gain control. So what that means is we're taking the raw signal that's coming in, we're compressing it, which is changing the dynamic range by clipping off where peaks are going too high, and then we're kind of, squishing the signal all together. And then if we want, we take the output gain and then we boost that whole squish signal up. And then past that, we have a Peak Stop Plus level control that says, don't go over this, right? And that is beneficial for I don't want to blow my speakers, right? You can just put the Peak Stop Plus level control at a certain section, and you're just never going to go over X, right? Or you're never going to push a signal more than X above. And so if you host an open mic, which I've done on occasion and I will do again in the future, you might want a compressor that has this kind of limiter so that if some jackass goes to unplug his or her acoustic guitar, that giant pop doesn't pop your, prosumer speakers that you're bringing around to the tasting room at a brewery or hipster food court or wherever your, traveling open mic is at. Generally the open mic at the nicer bars with their own sound people and stuff like that. They have slightly better systems in place, but they also very much have these limiters in place to hopefully not get that loud pop to be so loud that it tears their speakers. It doesn't get rid of the pop. It just limits how bad the pop can be, right? Oh, wow. Peak Stop Plus is typically used as a protective function. Creative effects can be achieved by intentionally driving the signal into heavy Peak Stop Plus limiting. Great care has gone into the design of the Peak Stop Plus limiter to keep it acoustically transparent. Appropriate use of it can protect your gear while keeping the signal free of artifacts. And that is our left to right to the stereo couple. It does have a Peak Stop Plus threshold LED indicator. This LED illuminates when the output signal exceeds the level set by the Peak Stop Plus level control, indicating the Peak Stop Plus limiting is occurring. Figure 4 illustrates the protective action of the Peak Stop Plus limiter. The signal with the thin line weight represents an unaltered input signal. As you can see, peaks of the input signal exceed the clamping levels. The signal the signal with the heavier line weight represents the output signal. The peaks of the input signal, which exceeded the clamping level, are not allowed to exceed this level at the output. This instantaneous protective action is invaluable for driver protection in speaker systems and for digital recording, where it is desirable to record as hot as possible while still avoiding the disastrous result of running out of headroom. I can't remember the guy's name. I'll maybe tag a comment if I can find it, but gain staging and headroom and all that with digital recordings, its own animal to think about. And this is important. This is a function you would want to utilize if you're going into, if I was recording my drum set into the AT920, I might want to put it on a compressor like this, because I don't want to exceed the headroom on my preamp on my digital recording audio card, right? So as you can see, DBX is exclusive. Peak Stop Plus is a technically advanced and superior, more marketing, limiting scheme for unrivaled system protection. And yeah, it's as typical as to set it to 2 decibels. So they set it pretty low. So okay, so let's go 0. Let's start the drum machine. And then let's push the output gain to see if we can get this threshold to light up on the Peak Stop Plus. Oh, yeah. So we could drive that limiter. So the kick is driving. Very interesting. Very interesting. Very interesting. Cool. Cool. All right, rear panel. I'm not going to go all the way around back to show you, so you can just look at the picture. AC power receptacle. Like I said, it's one of these D plugs. They gave me one at Atomic Music. AC power switch. I have it plugged in again. Like I said, I have it plugged in to this power one. So I just turn off that switch and I leave it always on otherwise. Audio inputs. Each channel features both XLR and 1/4-inch TRS tip ring sleeve. Electronically balanced inputs. Inputs may be used in a balanced or unbalanced configuration. My entire rig in this desk is unbalanced. That's by choice. That's my deal. Audio outputs. Each channel features both XLR and 1/4-inch TRS servo balanced outputs. Outputs may be in a balanced or unbalanced configuration. Unbalanced in, unbalanced out. An output transformer option is available when very long cable distance are required. See specifications. Operating level switch. This switch selects between a -10 dBV and +4 dBu nominal operating level. When the switch is in the in position, a -10 dBV operating level is selected. When it is in the out position, +4 dBu is selected. I did the -10 because it's all air quote professional equipment. Certainly if you're plugging like a couple of dynamic microphones or, passive, a couple of Shure SM58s right into the back, I would do the +4. You're using like, the crappy little Boss BX mixers that we like to overdrive. I probably would, any like consumer level, all that cheap shit you get at Guitar Center. I see everyone using. Yeah, I would definitely go +4 if it's inexpensive gear. And I mean by like it was inexpensive new, and it could be also inexpensive used. And -10 if it's anything decent, anything reasonable. Mackie, Allen and Heath. All the audio cards these days. I mean, even half the Behringer new audio cards are decent enough. I wouldn't consider them poor. Like the older stuff's pretty bad, but newer stuff. Yeah. Applications. All right. Fattening kick drum and compressing other drums. Weak, flabby kick drums often have too much boom and not enough slap. Too much boom and not enough slap. I hope that's on my tombstone. To tighten them up, start with the 1066 adjusted for a medium to high ratio. All right, so let's go medium to high ratio, 6:1. Adjust the threshold control so that the gain reduction meter shows 15 decibels of gain reduction. So let's kick. We're adjusting the threshold until we get to -15. There we go, right around 15. All right. Then increase the ratio if necessary. No, we're at 15. In over easy mode, the 1066 takes slightly longer to react than in hard knee mode. And will therefore emphasize the slap at the beginning of the note and reduce the boominess of its body. The 1066 also works well for tightening snare drums and tom-toms, not included on the Boss DR110, and can be used with drum machines to effectively alter the character of any electronic drum sounds. So with this setting, all right, bypass. Would you consider that a weak, flabby kick drum with too much boom and not enough slap? I mean, I'm not saying it's going from an 808 to a 909, 808's boom, 909's kick, right? I think most of us feel that. I think most of us think of it that way. Maybe you don't. Maybe I'm completely wrong. Let me know in the comments. But yeah, I'd say as a less weak, less flabby kick drum. Cool. Cymbals and tom-toms can be effectively compressed to help prevent tape saturation. So you use the sidechain send of the 1066 to send a signal to the input of an equalizer. And this is the one I was telling you again, like the equalizer sidechain trick, then connect the equalizer's output to the 1066's sidechain insert. The equalizer can be adjusted for boost with a peak at about 5 kilohertz, causing the cymbals to be compressed on a very loud crash, stopping tape saturation at high frequencies where there is less headroom. Oh, if you're using like a Porta Studio cassette, anything reel to reel, you definitely want to use like a decent-ish hardware dial and knobs like this. That's where it's at. However, gentle tapping of a drumstick or brushing of the cymbal will not be affected, assuming the tom-tom is a lower frequency instrument and can be better tolerated by the tape. It has less need for compression. Again, Espen Craft has a whole outboard compressor class that focuses on de-essing and using an EQ. It's a whole separate explainer. If I get a decent enough outboard EQ, I will do this trick with the compressor and the EQ when I do the EQ's manual. Equalization in the sidechain circuit means that the compressor is not triggered as readily by a loud tom-tom beat as by an equally loud cymbal crash. For drum kit submixes, e.g. mixing multiple drum tracks to 2 tracks while using both channels of a 1066 for compression, consider backing off the ratio on each channel down to 2:1 to avoid an excess of cymbal splattering. So it's saying, like we have drum machine into stereo, right? That if we back off the ratio, so where this was a good ratio for making a punchy kick and a good snare when it's the full mix, we should back the ratio down to 2:1 to avoid an excess of cymbal splattering, in quotes. In larger multi-tracking systems, compress the kick and snare separately. So on my live kit, I would likely use something like the 1066, where channel 1 would be the snare, channel 2 would be the kick. I would dial them each in to their own appropriate settings, right? And then maybe I would have like a bus compressor that's a totally different style of compressor. I think this is a perfectly suitable compressor. I've read, as I'm sure you all have read ad nauseum online, people saying, oh, it's a great compressor. No, it's a shit. It's a paperweight. No, you should only use this. Oh, buy my plugin. You know what I mean? People are crazy out there. So raising a signal out of the mix. This is another one of those graphic equalizer tricks. So if you reduce dynamic range to increase the average signal level by a small amount, a single track can be raised out of a mix by boosting its level slightly and applying compression. Start with a 2:1 ratio like this and a relatively low threshold setting, -20 dB. Adjust both controls as necessary. Compressors have also been used to bring vocals to the forefront of a mix in volume-restricted studios, e.g. home studios, like you see here. Start by adding a foam windscreen to the mic. Set the ratio to 10:1 and the threshold to -10 B. With your mouth approximately 2 inches from the mic, sing the vocal part, but with less volume than normal. Use phrasing to give the part some intensity. An equalizer, DBX 242 parametric equalizer or 30 series graphic equalizers, or a vocal effects device, reverb, delay, distortion, can be added to further define the performance. So again, if I get an equalizer in the future, I'll show you this trick. It is also possible to separate certain vocals or instruments from a mono program already mixed, refer to frequency-weighted compression on page 12. Note, when compressing a stereo program with a 1066, the factors affecting a compression curve and the actual ratio and threshold settings are the same as those previously covered with reference to single channels of program material. However, it will generally be found that large amounts of compression are more audible in a mixed stereo program than they might be on the separate tracks that were mixed to create the program. Smoothing out microphone levels. When distance is created between the vocalist and the microphone, there will be a variation in the signal level. Start with low compression, around 2:1, to smooth out any variations. Limiting also benefits intelligibility by allowing low-level input signals to be reproduced through the system at higher volume. Same thing for smoothing out musical instrument levels. Compression smooths out the variations of loudness among instruments. We often use this at open mics. We'll use compression for acoustic guitarists who do not understand dynamics. They do not know how to, not get too quiet and not be too loud. So you want to make it a little more consistently the same volume. Compression is where it's at. Likewise, I don't know, you want to record someone playing a flute or a saxophone, people that are kind of moving around. Now, you got other issues involved in making up these sounds, right? So you got your mics. This is a pretty good mic, but you'll notice when I come over here and I can hear me, but it's hard to hear me if I'm not speaking directly into the roadcaster. I tend to do an angle so I get less pops, right? If I'm talking like this, it's more poppy. If I'm going like this, I'm generally going across, but my voice is still pointed at the tip of the microphone. But yeah, the microphone is important, but the compressor can help. Prevent analog tape saturation tells you how old these instructions are. With programs of widely varying levels, compression can prevent recording levels from saturating tape tracks. And it's hilarious because now there's DSP algorithms that make fake tape saturation. It's hilarious to me. Go get a cassette player and saturate that tape. Speaker protection. Limiting is frequently used to prevent excessive program levels from distorting power amps and damaging drivers in a sound reinforcement system. To use the 1066 for speaker protection, set the 1066 for limiting. Over easy button disengaged, ratio set to 10:1 or greater, auto button engaged. Then set the threshold to +20. Adjust the system for the desired amount of level while ensuring the amplifier doesn't clip. Once set, lower the 1066's threshold until gain reduction just begins to occur. Then raise the threshold slightly so that the signal is just beneath the point where gain reduction occurs. It is possible for momentary peaks to slip through before the limiter has time to react. Additional protection can be achieved by using the Peak Stop Plus limiter instead of the 1066's compression circuit to apply limiting. All right, so it's telling you, the Peak Stop Plus, that's the thing that's going to keep you from ruining your sound system or blowing an amp or whatever. But there's also a more subtle way to use the limiter to get to speaker protection. You can use the same technique previously mentioned to set this up. Just use the Peak Stop Plus control rather than the compression threshold control. Peak Stop Plus limiting can typically limit overshoots to a maximum of 2 decibels, but may soften transients ever so slightly. Preventing digital recording overload. So this has tape saturation and digital recording overload both mentioned. What a wonderful time in the world where both were still prevalent enough to make it into the manual. All right, some digital recorders and samplers, and this is a big deal. So those of you who are out there with your SP404s, your 303s, 202s, your MPCs, whatever, you're coming off a record player, you're coming off a cassette deck, you're coming off of a VHS tape for a sample or whatever, the compressor can really help you. The compressor can help. Also, I think I'm going to have to buy an EQ and do a demo because the EQ can help you really carve out some samples before they even get into your sampler. So that'll be an interesting thing to take a peek at. So yeah, so they produce audible distortion when they exceed their headroom. That's true. The range above their maximum operating level. The 1066 effectively ensures the audio input does not overload a digital recorder's analog to digital converters. The 1066 can perform this function quietly enough for all digital media. To use the 1066 so that no changes in gain occur unless an emergency arises, wildly excessive levels, set hard knee mode on, the ratio to infinity to 1, and the threshold to the highest permissible level. Note, peak stop plus limiting can also be used to prevent raucous sounding digital overload. That should be the name of my next album, Raucous Sounding Digital Overload. I'll write that down. Shit. Yeah, whatever. Later. Gating dry percussive sounds. To effectively gate percussive sounds with a high level transient, you need to set the 1066's gate controls to ensure that the gate is less sensitive to nearby signals that would cause the gate to open or false trigger. Set the expander gate ratio setting high enough to enable the gate to close abruptly as the signal decays below the threshold. So you heard that at the beginning when I demoed that with the different symbols on the DR110, right? And it's interesting because like you'll find a dozen or 100 even explainers of like Phil Collins invented gated reverb, Prince loved gated reverb. I think Vox did a particularly good thing about gated reverb and how everyone just loves it. It's also interesting because the limit of sample time does a similar thing to gating where it cuts off the signal. Like it says, oh, you know, we can't give you a full 1.2 seconds for a full cymbal decay. So the cymbal of the snare has this tail that just abruptly stops. And the gate in a compressor does the same thing that the gated reverb algorithm and the limitations of a sampler and all these other things that give you that gated sound. You can do that in an interesting and different way here as well. And you can totally do it in a DAW. This happens to be a way to do it analog, outboard, whatever, if that's what you want to do. Right? So yeah, set the expander gate. We went through that. Fast expansion of sustained low frequency signals can result in chattering because the 1066 is capable of extremely fast expansion. Make sure the ratio is not set too high in these applications. The proper threshold setting will also minimize false triggering and chattering. These types of settings are most useful for tightening up drum tracks, removing the ring from some drums, or gating out the leakage of one drum through another's mic. That's a big deal in these, bedroom, spare room, home recording studios. We definitely don't have I've been to professional studios that don't have good drum mic isolation. Gating sounds that have longer decay, e.g. cymbal and piano. To effectively gate sounds which have more decay after the initial transient, set the ratio control low enough to allow the gate to remain open and capture the signal's entire envelope. And that's also what we talked about at the beginning when we were demonstrating the gate with the different cymbal in the drum machine with the DR110. Changing sound quality. The 1066's expander gate can effectively change the sonic character of a sound because it can reduce or otherwise alter the quality of instrumental ambience and reverb. For example, as an instrument stops, its reverberation level will fall through the 1066's threshold setting, can now be made to die out more quickly, faster than the natural delay of the sound. Experiment with different threshold and ratio settings to change the tail of the sound. A high ratio setting will nearly eliminate reverb. Keyed gating. Keyed gating, that is, controlling the gating of one signal by another, can be used to add dynamics to a sound, e.g. creating perfectly in-sync playing and overdubbing among individual instruments or fattening a dynamically weak track. To create two distinct channels of bass guitar for your mix by splitting the bass signal into two channels and synchronizing one channel of bass guitar with the kick drum, start by feeding one channel of bass directly into the mix and the other into the gate's input. Then key the gate with a signal from the kick drum connected to the sidechain input, adjust controls as needed. The gated bass track will now open with each kick, adding punch and dynamics. This can really tighten up the tracks and add life to the mix. Another example of keyed gating is using the drum signal to key an oscillator, which is set to an appropriate frequency to tune and punch up the drum sound. I'm definitely going to figure out how to demo those two things in a future video. Keyed gating, very cool. Note, for all keyed gating applications, so EQ, keyed gating demos. Be aware to adjust the compressor accordingly or bypass it by setting the compressor ratio fully counterclockwise to 1:1. Frequency-sensitive gating. Frequency-sensitive gating lets you use the sidechain input to tune the response of the gating action. For example, if you're gating a kick drum in a track with lots of leakage, you can tune into the frequency of the kick with an out. This is more that outboard EQ stuff. Again, go watch Espen Craft's video. The gate will respond to only that drum. Feed the kick drum signal both directly into the gate and also through an equalizer, which is connected to the sidechain input with equalizer adjusted so that only the desired signal is emphasized at the sidechain input. The gate becomes even more selective in opening. Frequency-weighted compression. It is possible to separate certain vocals and instruments from a mix by frequency-weighted compression. With an equalizer inserted ahead of the detector input in the sidechain, not the audio path, the equalization settings do not shift the timbre of frequency response of the audio signal. They merely alter the threshold response of the compressor on a frequency-weighted basis. With this arrangement, raising certain frequencies on the equalizer causes them to be suppressed in the audio signal. A relatively high threshold setting can allow normal sounds to be unaffected while solo and very loud sounds are held back, of course. When compression does occur, the level of the entire program is affected. Depending on the threshold settings, lower level fundamentals or harmonics will not cause compression, and the program is not subject to the phase shift normally caused by program equalization. During the recording of cymbals and tom-toms, a compressor with an equalizer in the detector path can help prevent tape saturation. The equalizer can be adjusted for boost with a peak of about 5 kHz, causing the cymbal to be compressed on a very loud crash, stopping tape saturation or digital overload at high frequencies where there is less headroom. However, gentle tapping of a drumstick or brushing of a cymbal will not be held back, assuming the tom-tom is a low, and this is the same stuff they said before. Assuming the tom-tom is a lower frequency instrument and can be better tolerated by the tape, it has less need for compression. The equalization in the detector circuit means that the compressor is not triggered as readily by a loud tom-tom beat as by an equally loud cymbal crash. The converse of the above EQ technique can be used. Dipping the equalizer bands causes any sound with dominant energy in the affected register to pull the level up because the 1066 will detect a need for less compression. Frequency-weighted compression for multi-way speaker systems. If a single compressor is to be used with a multi-way speaker system before the crossover after the EQ, the system operator is faced with the problem of keeping levels below the point of destruction of the most sensitive part of the system. If, for example, mid-range drivers are frequently damaged, the whole system must be operated at a lower sound pressure level, or additional mid-range drivers must be added. But inserting an equalizer in the detector path sidechain of the 1066, it can be made more sensitive to frequencies in the range handled, it looks like hand-led, I'm like, in the range handled by the sensitive drivers. The system can then be run at higher levels and will only be dropped back when damaging signals are present. Pre-emphasis for broadcast applications. By inserting a pre-emphasis filter network in the detector path, the 1066 processing pre-emphasized audio, higher levels can be run within the headroom limitations of the broadcast chain. This is a very specific item, pre-emphasis filter network. I've never had the pleasure of touching one. Anticipated compression. By feeding the program directly to the 1066's sidechain input and sending the audio signal through a delay line before the audio input, the unit can anticipate the need for a gain change. With some experimentation, the effect can be that of 0 attack time at any given frequency. Additional signal delays beyond this 0 time will then cause the compressor to finish reducing the gain before the leading edge of the loud passage even enters the signal input. This will suppress the program material preceding this loud passage. The 1066 will then begin to recover from compression release before the loud passage has dropped back down toward the set threshold. This will cause the output level to surge higher as the note or passage should be decaying. Installation considerations. This is the tail end of it. So 1066 is designed for nominal -10 or +4 dB levels. The 1066 can be used with either balanced or unbalanced sources. And the outputs can be used with either balanced or unbalanced loads, providing the proper cable is used. Balanced line is defined as 2-conductor shielded cable with the two. So this is a lot of like another CYA cover your ass stuff. Use the right cable. You know, if it's unbalanced and you get some noise, you could have a ground issue. This is the standard for, you know, if you're making your own cables, make sure you make them like everyone else. Type in 3 to the ground for unity gain and out of the 1066 when using unbalanced input connections to balanced output connections. It's just a lot of basic cabling stuff. The following cable wire diagrams may assist you with input or output connections for both balanced and unbalanced connectors. This is literally how to make the connectors on a cable. We do not need to read all of that. And then finally, we have the specifications. And this goes back to what we talked about originally. You know, max input, 24 dB, balanced or unbalanced. It's got a lot of details. I do not consider this any real part of the instructions. So yeah, specifications, right? And then it's got like, I don't know how to explain to you. Like, look at this. It's got like 5, 6, 7 pages of notes here. 1, 2, 3, 3 blank pages left just for notes for you to take the end of the instruction manual. And that, my friends, is a fucking manual for the DBX 1066 compressor limiter gate. I hope you enjoyed my very first let's read the fucking manual. Enjoy the rest of your day. Cheers.